Hello everyone. In this particular video, we are going to solve the problem number 1.43 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A particle A moves along a circle of radius r is equal to 50 centimeter. So this is the circle in which the particle is moving, and the radius of this circle is 50 centimeter, so that its radius vector r relative to the point O rotates with the constant angular velocity omega is equal to 0.4 radian per second. So this particular point O is fixed, and the point A that is moving in this particular circle with the angular velocity of 0.4 radian per second with respect to this point O, and it is asking to find the modulus of the velocity of the particle and the modulus and direction of its total acceleration. Okay, so let us say that this is x direction by joining the line of O and let us say B, and this is y direction. Okay, let us say this particular angle is theta. This particular angle is theta because this is the radius and O to B is also radius, so that's why this particular angle will also be theta, and this angle will be theta plus theta is equal to 2 theta. Now we have to find out, let us say this particular angle will be 180 minus 2 theta. Okay, and in the triangle OAB, the radius r is equal to 50 centimeter is given, but we don't know the value of r, and that will depend upon theta as it is moving on this particular circle. So for that we will apply the sine rule in triangle OAB. Okay, so we can write small r divided by sine of opposite angle, that is 180 minus 2 theta, is equal to r divided by sine of opposite angle, that is theta, and sine of 180 minus 2 theta is equal to sine of 2 theta. Okay, so from here we can write small r is equal to r times sine of 2 theta divided by sine theta, that we can equate it to r times 2 sine theta cos theta whole divided by sine theta. Here sine theta will get cancelled, and we will get 2r cos theta is equal to small r. Okay, so this is the value of small r we got, that depends upon theta. Okay, now if we write the position vector of A, so that we can write it at, let us say the position vector of A is equal to r cos theta I cap, that is the component in the x direction, plus r sin theta into j cap. Okay, and here we have got r is equal to 2r cos theta, so let us substitute here. So we will get the position vector ra is equal to r times 2r cos theta into cos theta I cap plus 2r cos theta into sin theta j cap. So from here we will get 2r cos square theta I cap plus r times 2 sin theta cos theta j cap, and we know that 2 sin theta cos theta is sin 2 theta. So we can write the position vector is equal to 2r cos square theta I cap plus r times sin 2 theta j cap. Now we have to find out the magnitude of the velocity. For that we will differentiate this particular position vector. So we can write velocity vector is equal to d by dt of ra vector is equal to d by dt of 2r cos square theta I cap plus r times sin 2 theta j cap. Okay, let us differentiate this particular vector. So we can write 2r times d by dt of cos square theta I cap plus r times d by dt of sin 2 theta j cap. Okay, so the differentiation of cos square theta is 2 cos theta into the differentiation of cos theta is minus sin theta, and the differentiation of theta is d theta upon dt I cap plus r times differentiation of sin 2 theta is cos 2 theta into differentiation of 2 theta is 2 times d theta by dt into j cap. Now here, what is the value of d theta by dt, that we don't know. For that, it is given that the angular velocity is 0.4 radian per second. So here we can write omega is equal to minus d theta upon dt, because this particular angle theta is decreasing as it is moving in this particular direction. Okay, so we will substitute the value of d theta by dt. D theta by dt is equal to minus omega in the expression of velocity vector. So we can write the velocity vector is equal to 2r into 2 sin theta cos theta into omega I cap plus 2r times cos 2 theta into minus omega j cap. Okay, so from here we can write the velocity vector is equal to 2r sin 2 theta, because 2 sin theta cos theta is sin 2 theta into omega I cap plus minus 2r omega cos 2 theta j cap. So this is the velocity vector we are having. Now let us find out the magnitude of this particular velocity vector. So we can write the magnitude is equal to, as both x and y both are perpendicular to each other, so we can write 2r omega sin 2 theta whole square plus 2r omega cos 2 theta whole square. So from here, if we take the common, that is 2r omega, so we will get 2r omega sin square 2 theta plus cos square 2 theta under root. So this particular expression is nothing but 1. So we will get the velocity vector is equal to 2r omega. Okay, so this is the expression of magnitude of velocity we got. Now in the second part, it is asking to find the direction and modulus of total acceleration. Okay, for that let us differentiate the velocity vector. We can write the acceleration vector is equal to derivative of velocity vector with respect to time, that is d by dt of, this is the velocity vector we got, that is 2r omega sin 2 theta I cap minus 2r omega cos 2 theta j cap. Okay, so from here we can write 2r omega is constant, so as it is, and d by dt of sin 2 theta I cap minus 2r omega d by dt of cos of 2 theta j cap. Okay, so from here we can write 2r omega, differentiation of sin 2 theta is cos of 2 theta, and the derivative of 2 theta is 2 times d theta upon dt I cap minus 2r omega, differentiation of cos 2 theta is minus sin 2 theta, and the differentiation of 2 theta is 2 times d theta by dt j cap. And we know that d theta by dt is equal to minus omega, so let us substitute the value of d theta by dt here. So we can get 2r omega cos of 2 theta into minus 2 omega I cap minus 2r omega or plus sin 2 theta into minus 2 omega j cap. So if we simplify this particular expression, then we will get minus 4 r omega square cos 2 theta I cap minus 4 r omega square sine 2 theta j cap. So this is the acceleration vector we got, and the magnitude of this particular acceleration vector we can write it as w vector mod is equal to minus 4r omega square cos 2 theta whole square plus minus 4r omega square sine 2 theta whole square under root. Okay, so from here if we take the common, that is 4r omega square, we will get 4r omega square cos square 2 theta plus sine square 2 theta under root, and cos square 2 theta plus sine square 2 theta is 1, so we will get the magnitude of the acceleration is equal to 4r omega square. Okay, so this is the expression of the magnitude of acceleration vector, and here we have got the magnitude of velocity vector. I hope the entire procedure is clear. Thank you.